Dear students, we are going to look at a very important concept of vector differentiation, that is nothing but directional derivative. Directional derivative, as the name itself suggests, you are going for a derivative but in a specified direction. So a typical question appears like this. I'll just directly go into the details of how to find the directional derivative rather than explaining what is directional derivative. So find the directional derivative. Find the directional derivative of some scalar function will be given to that problem. Okay, x square plus xyz square. At some point it will be supplied. Suppose for example 2 comma 0 comma minus 1 in the direction of, for the direction some vector should be given. So in the direction of the vector 2I plus j minus k. Now 3 inputs will be there in the problem always. That 3 inputs will be, one scalar function will be supplied to us, one point will be supplied to us, and one vector for the direction will be supplied. So the working method is very simple. There are 3 steps basically. I will go step by step. First, you just give the name as some phi for the scalar function given, x square plus xyz square. Then in another video I have recorded how to calculate the gradient. So now we will calculate del phi. Del phi is nothing but derivative of phi with respect to x multiplied with I plus dou phi by dou yj plus dou phi by dou z k. So let's write it directly. So the first term derivative will be 2x plus, with respect to x, yz square is constant, x derivative is 1. So this comes along with I plus this function. Now again I have to take with respect to y. So first term will be 0. With respect to y, xz square is constant, so xz square. So let me cancel this. So with respect to y, first term derivative is 0 and xz square will be there as it is. Y derivative is 1, so that comes along with j. Now when I come up with dou phi by dou z, x square derivative is 0 and xy will be as it is, xy will be as it is, and z square derivative is 2z. This comes with k. So this is del phi. So finding del phi, and then next is substitution of the point. Therefore del phi at this point, at the point 2 comma 0 comma minus 1, in the place of x I will substitute 2, in the place of y I will substitute y, in the place of y I substitute 0, in the place of z I substitute minus 1. So substitution of this gives one vector. That vector is equal to, so when x is 2 it will be 4, because y is 0 that is gone, so it will become 4I, and when x is 2 and z is minus 1, so that will become plus 1 into 2 is 2, so it will be 2j. And third one, last, because that y is 0, this completely gone, so del phi is this one. Now this is completely one part. Whatever scalar function is given, find the gradient, substitute the point. So this part is one part. Second part is, you have to create a unit vector, call it as E. Suppose let E be unit vector in given direction. The direction is given as 2I plus j. Here you see 2I plus j minus k. 2I plus j minus k. So therefore that E bar is equal to, we have to divide that given vector with the length of that vector. So that divided by square root of whatever I coefficient is there, we have to square this one. So I write it as 4. Whatever j coefficient is there, that is 1, I have to square and add it here. Whatever k coefficient is there, I have to square and I have to add it, so it will be plus 1. So it will be nothing but equal to 1 by root 6 2I plus j minus k. So this is the unit vector in given direction. So this is second part. Don't draw the lines in the examination. I would just want to show you that how many parts are there in that. First is finding del phi and substituting the point. Second is finding the unit vector in given direction. The last step is therefore required directional derivative. Required directional derivative means whatever directional derivative we want, that is nothing but the dot product of this del phi, whatever del phi we got at a given point, and this particular e. The dot product of these two is the result which we require. Now I want the dot product of this particular 4i plus 2j and this one. I want the dot product. So how should I take the dot product? In the basics of this particular unit 4 I said it. However, that's so simple, you can easily get it. That constant 1 by root 6 I am taking outside. Now I will multiply with the I coefficient 4 and this I coefficient 2. I will multiply that one. I'm sorry. So I remove that one. So 4 into 2. Now j coefficient into j coefficient, that is 2 into 1, and the k coefficient is 0 in this particular del phi. So it will be 0 into this particular minus 1. That is not required actually because it becomes 0. So finally it is 6 plus 2 8. So it will be 8 by root 6. This is what is our required directional derivative. I hope you understood.